All right, so if we're taking, rubies, so many things. Okay, and then we are underlining the question: how many more yards of fence will Dan need to surround his yard? He needs 7 5/6 yards of fence to surround his backyard, and he has 3/4 of 3 1/4 yards of fence. All right, so that is 7 5/6 minus 3 1/4 are our key concept is mixed number subtraction, not just fraction subtraction, but mixed number subtraction. And then if we look at this one, we can turn this one into the kindergarten problem and the fifth grade problem. Our kindergarten problem will be 7 minus 3. Our fifth grade problem actually works. Hooray, saves us some time. We don't have to use the whole times denominator plus numerator. The reason why is we can tell 1/4 is smaller than 5/6, so it's going to work. Just like we did in our warm-ups, just look and make those connections. If 1/4 is smaller than 5/6, then we can do that as a fifth grade problem. If 1/4 is, or I mean, if we have to take something away that's bigger, then we have to turn it into a improper fraction. All right, so we can find a common denominator by skip counting. Once again, we're doing this. We did these before on a different problem, so we remember that 12 works. You get a common denominator of 12. So what I'm going to do is I'm going to multiply 2 snowmen. 6 times 2 equals 12. 4 times 3 equals 12. So I have a total of 10 twelfths minus 3 twelfths, which gives me 7 twelfths. And then I'm going to combine my 7 twelfths back here with 7 minus 3, which is 4. So I have 4 over there, which gives me my total answer of 4 and 7 twelfths. Remember, we know that 7 is prime, so it doesn't fit evenly into 12, so you can't simplify. Once again, if you have a prime numerator and it doesn't fit evenly into your denominator, you have a simplified fraction. So 4 and 7 twelfths is our answer. So on these next ones, just go ahead and kind of work through them. And then, so there's going to be a lot of pausing and going because they're just blank problems. So work on this one, go ahead and pause. All right, welcome back. 10 twelfths minus 2 sixths. Are our denominators the same? Nope. Can I turn one into the other using multiplication of whole numbers? Yes. 6 turns into 12 by multiplying times 2. So this is 10 twelfths minus 4 twelfths, which gives us 6 twelfths. Our numerator is half of our denominator. So that's 1/2. You got 6 twelfths, great. But remember, it is 1/2 if we are going to absolutely get our simplified fraction. And remember, if you, for some reason, only divide it by 2, which happens because you're like, they're both even, teacher dabbing, right? That only got you 3/6, which still can be simplified, right? And 3 is half of 6. So if you divide it by 3, it'd be 1/2. So 1/2 is your absolute simplified answer. All right, next one. 3/5 minus 1/3. This one, can we, are our denominators the same? No. I hope you paused and came back. All right, and then can I turn a 3 into a 5 using multiplication of whole numbers? No. Can I turn a 5 into a 3 using multiplication of whole numbers? No. But can I make a skip count chart? Yes, and find out what number both of these make? I absolutely can, and I already found it. It's 15, right? So I can turn 5 into 15 by multiplying times 3, which was the opposite denominator. So sometimes it works out like that. As you can see, 5, 5, 3, 3. So it works. 9/15 minus 5/15 equals 4/15. And our denominator is odd. 4 doesn't go evenly into 15. 2 doesn't go evenly into 15. So none of the factors of 4 go evenly into 15. So 4/15 is actually simplified. All right, and then I think there's one more. So here we go. Let's try it. 6 2/3 minus 3 1/7. We can turn this one into a kindergarten problem and a fifth grade problem. 6 minus 3 is 3. I cannot turn one denominator into the other, but I can multiply times the opposite. And that gives me 14/21 minus 3/21, which is 11/21.